Okay, good afternoon. Today we are going to be talking about parabolas once again. We have already seen parabolas in the sense of, right here, y equals ax squared plus bx plus c. We have already always seen parabolas that have a squared value for x. When x is being squared, you get a parabola that either points upwards or downwards, depending on the a. That's a function. Today, though, we're going to learn how to deal with all parabolas, both functions and non-functions. Non-function parabolas are when y is squared, and they're going to be opening sideways. So these are not functions because at any particular x value, you have two different y values. And you cannot have two different y values for the same x value. So today we're going to learn the other side of parabolas, the non-function side. Now, as I described yesterday, okay, a parabola, just like a circle, can also be obtained by slicing a double cone on a slant, as shown below. Any figure that can be obtained by slicing a double cone is called a conic section. We have already learned about circles, and today we're going to talk about parabolas. So all of these conic sections, again, they're called conic sections because they come from a double cone. All right, so how does this work? Well, a parabola can also be defined, guys, whether it's a function parabola that's an x squared or a non-function parabola that's a y squared. It can also be defined as the set of all points in a plane that are the same distance from a given point called the focus and a given line called the directrix. The parabola below has a focus of 2, 3. Okay, this is the focus right here of 2, 3. That's my focus. And the equation of the directrix is y equals -1. The y equals -1 is right here in blue. This guy right here. Okay, that's my directrix. What they're saying, okay, and this is what happens in parabolas. The distance from any point on the directrix to any point on the graph will be the same distance as the distance from that point on the graph to my focus. So what happens here? If I have a point, let's say, here, the distance from that point to the focus will equal the distance from that point to the directrix. If I have a point here on the graph, the distance from that point to the focus will equal the distance from that point to the directrix. So a parabola is a series of points where the distance from any point on the line, on the graph, the distance to the directrix and to the focus is equal. That's what a parabola is made of. Okay? So, what are all of these things? Let me just explain a couple things to you. Okay? First of all, you know that this guy here going through the vertex, that's called my axis of symmetry. Awesome. You know this point here, even though it's not labeled, that's my vertex. Very good. Okay? This point here is just an XY. That's a point on the graph. This focus, okay, this is the focus. If you could tell, look at some things that are easy to recognize. The focus is always going to be above the vertex. Always. Always going to be above the vertex, or to the right of the vertex, to the left of the vertex. If I have a graph that's going up like this, here's my vertex, my focus will be up here. If I have a parabola that's going downwards, here's my vertex, my focus will be right here. If I have a graph that is going to, opening to the right, it's a y squared, there's my vertex, there's my focus. If I have it opening to the left, there's my vertex, and here's my focus. So the focus will always tell you kind of the direction in which the graph is going to be pointing. Yes, sir?
But
Absolutely it matters. There's an exact location for the focus. Now, so the focus will tell you which way it's going to point. If it's above the vertex, you're pointing upwards. If it's below the vertex, you're going downwards. If it's to the right of the vertex, you're opening to the right. And if it's to the left of the vertex, you're opening to the left. Okay? And then this directrix. This directrix is just a line that is used, just like the focal point of the focus. It's used to prove that the given shape is a parabola. And then this line here, this green line here, it's called the latus rectum. And the latus rectum is, to be exact, it goes from one point on the parabola to another point on the parabola going through the focus. That is also sometimes called, the latus rectum is also sometimes called the focal length. The focal length. Okay? All of this right now is Chinese, and it should be. And it should be. That's good. We're going to get into some stuff right now. Let me first prove to you, okay, that the distance from the focus to point XY is equal to the distance from XY to the directrix X negative 1. If I am being accurate in my definition, the following statement must be true. And I'll go ahead and just erase this for a second so that it's a little clearer. What we're saying is that the distance from XY to 2, 3, remember what I said, the distance from any point on the parabola to the focus must be equal to the distance from that same point XY to a point on the directrix X negative 1. Does that part at least make sense? Guys? Okay. So now let's prove it. And we prove it very easily. If you remember, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. I'm going to have two different distances, aren't I? Yep. Right? And I'm going to have to prove they're both equal. So, let's do it. I've got x minus 2. Remember, this is, let me label this for you guys so you could keep up. This is x1, y1, x2, y2. That's for this first equation right here. This is x1, y1, x2, y2. That's for this equation right there. Okay? So I've got x minus 2 squared. That's x1 minus x2 squared plus y minus 3, which is y minus y squared, equals, yes, sir? It doesn't matter. x2 minus x1 or x1 minus x2, they're interchangeable because in the end you're gonna square them. So thank you very much. And then for the blue equation, x minus x squared plus y minus a negative 1 squared. From there, you're going to have the following. Let me erase the colors now. You're going to have the following. I'm going to square both sides, right, guys? I hope you remember that from our radical chapter. That's why we learned that, so we could learn how to deal with radicals. That went bye-bye. And now I'm going to go ahead and square everything, simplify it. So I'm going to go ahead and see what I have there. Okay. Hopefully you see the math here that I'm doing. See what I did here? I did y minus 3 squared, which is y squared minus 6y plus 9. X minus x is 0, so that went bye-bye. And then this is y plus 1, which when I square is y squared plus 2y plus 1. Notice how the y squareds cancel here, okay? Now, I could go ahead and extend that, but I'm not going to. I'm going to show you why now, okay? When I go ahead and do everything, excuse me, I'm going to get x squared, x minus 2 squared plus 8 equals 8y. And that's literally it. Okay? How did I get that? I brought over my 6y. Okay, I brought over my 1 to the 9, and that is my equation. And then I went ahead and divided everything by 8. And then I have this bad boy right here. Okay? It is the vertex form, sir. Thank you very much. That's why I kept the x minus 2 squared, because x was being squared, so I left it in vertex form. Now, I may not ask you to do that. I may ask you to do that. So I really hope you understand how to use this distance formula. Because I may ask you, I may say, prove that the focus is 2, 3. Or I may say, prove that this situation, write an equation for it. Well, I'd say to write an equation, you're going to have to set up the distance from the focus to a point on the graph equal to the point of the graph to the directrix. You with me so far? A lot of math in this one. Okay. Now, let's get to the good stuff. This is still the Mickey Mouse part. Now, let's get to some more Mickey Mouse. Just a blast from the past. Remember, equation of the parabola, when it's a function form, when it's in a function form, is y equals a times x minus h squared plus k. We're going to show it to you later, but for the non-function form, it would be x equals a times y minus k squared plus h. Okay, that's what it would be when it's the non-function form. Because when y is squared, it's a non-function. Okay? If in the function form, a is greater than 0, we know that it's going to be pointing up, like the red letters correspond to the red graph. If a is less than 1, if it's negative, then it's going to be pointing down like the purple. Okay? For the non-function one, okay, if a, for the non-function one, when y is squared, okay, when y is squared, if a is less than 0, it's going to open up to the left. And we will go over all of this in greater detail. If a is greater than 0, then that means it's going to open up towards the right. Okay? So in a function form, when x is squared, if a is greater than 0, points up. If a is less than 0, points down. If when y is squared, the non-function form, when y is squared, if a is less than 0, it opens to the left. If a is greater than 0, it opens to the right. Now, I'm about to bombard you with a lot of information here. So please ask questions and please focus. Okay. Now, the general table using a vertex form of a quadratic. Okay. These are the new forms that we are going to try to work with. Not try. These are the new forms of the equation that we are going to work with. You're going to turn it in to stuff like this through completing the square and doing all that fun jazz. And the formula, okay, we're going to first look at the x squared one. This is the function, because x is being squared. This is the non-function, because y is being squared. So, I've got x minus h squared. That's kind of just like the vertex form. We know that h makes it go left and right. Equals 4a times y minus k. The vertex is your h and your k. That's pretty simple. That's like from before. Remember your axis of symmetry? Axis of symmetry was the h value of the vertex. So your axis of symmetry is x equals h. Okay, it is an equation. So you have to put the x equals h there, guys. You have to. The focus, that's that point that we use to prove that it is a parabola. The focus is going to be the h, comma, k plus a value. Your a is over there. Your directrix, that's also what is used to prove that you have a parabola, because again, the distance from any point on the parabola must be equal to both the focus and the directrix. The directrix equation is a y equals k minus a. Direction of opening, we already went over that. If it's positive, it goes up. If it's negative, it goes down. And I'm sorry, this should not be less than or equal to. That should just straight up be less than. So I apologize about that. This should not be there. And that should not be there. And that should not be there. And that should not be there. Sorry about that. Okay. And then the last thing, the length of the lattice rectum is the absolute value of 4 times a. When we look at that graph, we'll check the right graph now in a second, but when we look at the function graph, again, look at what we have here, guys. We have the parabola in blue. We have the vertex in orange, which is down here. Okay, right here. This guy. You have the vertex, the focus above it right here in green. Okay? And this bad boy down here, that's my directrix. Remember, any point on this line must be equal in distance to both the focus and the directrix. Those two lengths must be equal. That's what proves a parabola. Now, let's look at the other one. Now I've got the non-function parabola. Y minus k squared equals, yes?
You have the vertex, if k and h would be positive, they would be negative in the vertex. But it's minus k minus k.
Come again? No, if it says x minus 5, the h is positive 5. It's opposites.
Yes, opposite.
Yes, if I have x minus 5 squared, then that h is 5. So anyways, the non-function quadratic. I have y minus k squared equals 4a times x minus h. The vertex is hk. The axis of symmetry is this time y equals k. Please be careful, because remember, this graph, it's opening to the right or to the left. The focus is h plus a, comma k. The directrix is an x equals h minus a. If a is greater than 0, it opens to the right. If it is less than 0, it opens to the left. And the lattice rectum is still 4a. All right, again, you got your directrix, you got your vertex, you got your focus, you have the parabola, and your lattice rectum would go right here, because it goes from one point of the parabola to the other, going through the focus. It's also called the focal length. A couple things for you guys to be aware of, okay? I think this is going to help you. Please remember that once you have your vertex, and I have an x squared, the vertex h is equal to the axis of symmetry, right? Hello? Right? And when you have a y squared, the k of the vertex is the axis of symmetry for that y squared. Okay, also another thing. When you have x squared and you have a vertex h, right? That h is also the h of the focus. I promise. Last thing that you may want to try to remember. When the axis of symmetry is an x equals, the directrix will always be a y equals. When the axis of symmetry is an x equals, the directrix will always be a y equals. Reversed on the y squared. I have my hk. My k is my axis of symmetry. Well, my k is also the value for the y value of the focus. When I have a y equals axis of symmetry, I'm going to have an x equals directrix. This is not going to come to you in 3 minutes. This is not going to come to you by the time I finish this class. This is going to come to you by a lot of repetition, my friends. And you will not be given the formula sheet. So you must learn them, okay? Now hopefully you understand that sheet. Now let's get to work. Let's put all of this stuff into play, okay? I want to graph the equation y squared equals negative 12x. All right. First things first, my friends. The vertex. is, what's my k and what's my h here? 0. Very good. So my vertex is 0, 0. Right? The focus. What will my focus be? Look back at your equations here. This is a y squared, right? So what is the focus going to be here? H plus a, comma, k, right? So remember what I said? When it's y squared, the vertex k will be the focus k, right? And what is my x value going to be? No. Negative 12 equals 4a. Divided by 4, a equals negative 3. Guys, look, 4a, with all due respect, I already showed you. So instead of just complaining, my friends, I told you this is going to be a little bit of a time to adapt, but that's 4a. So please don't talk to me like I'm crazy. Okay, so 4a equals negative 12, so a equals negative 3. So what did you say the focus formula was for a y squared? H plus a, right? Isn't my h 0? So this is negative 3, 0. My directrix. What is the formula for the directrix? Remember, the axis of symmetry here is a y. It's an x equals, right? No, guys. What is the directrix for a y squared? Please look at your formula instead of guessing. It's x equals h minus a. So x will equal 3 in this case. Okay? And now, I was going to make you do a test point where you can find the point on the focus, the x of the focus, and plug it in. But that's a mission. Why don't we, instead of do a test point, why don't we just find the length of the lattice rectum? And you'll see how much easier this is. The length of the lattice rectum is the absolute value of 4a, correct? So in this case, it's the absolute value of negative 12, correct? So the distance of the lattice rectum is 12. You guys with me? Okay, now, here's the easy part. Vertex is 0, 0. Focus is negative 3, comma 0. So 1, 2, 3. Is it going to open to the left already, or to the right, or up or down already? To the left. Okay. X equals 3 is my directrix. So x equals 3 is my directrix. And my lattice rectum, the length is 12, right? So from my focus, I'm going to go up 1, 2, 3, 4, 5, 6. And down 1, 2, 3, 4, 5, 6. Because isn't 6 plus 6, 12? Connect the dots. You're done. That's your graph. And that's your lattice rectum right here. You don't have to graph the lattice rectum. You just need the length of the lattice rectum to find those 2 points on the graph. We have 6 examples today, so there'll be plenty of time. You're done. That's exactly right, sir. It's just a matter of remembering the formulas, my brother. Yes, sir. Sir.
Would the focus always equal the directrix always equal the negative focus?
No. It will not always equal the negative focus because remember, in this case, we didn't have an H. But thank you for asking, sir. Yes, sir. Shh. Come again? How wide? Because I put these points right here. This is actually much easier than doing it the old way, guys. With the negative b over 2a and all that stuff. It's much easier, actually. It's just a matter of getting the hang of it. So again, let's continue. Let's graph this equation now. X squared. So we know it's an x squared. So it's positive 4a. So I know I'm going to be going up. Okay, what's my vertex here? 0, 0. That's absolutely right. Now it's an x squared. So what is my focus going to be? It's going to be 0, comma h. No, it's not h plus k for the focus. It's k plus a. K plus a. So in this case, it's going to be 0, comma 2. Excellent. My directrix, it's not just negative 2. What kind of an axis of symmetry is this going to be? This is goes up like that. So it's going to be an x equals, correct? So if it's an x equals axis of symmetry, what would the directrix have to be? If it's an x equals axis of symmetry, the directrix will be a y equals, and it's going to be k minus a, so y will equal negative 2. Again, we're not going to do a test point, okay? Instead, we're going to just find the length of the lattice rectum, which is 4a, which in this case equals 8. So, now, I get my vertex, which is 0, 0. My focus, which is 0, 2. You can tell already it's going to be pointing upwards, because whenever the focus is above the vertex, that's the way the parabola follows it. And then from this focal point, I'm going to go to the right 4, 1, 2, 3, 4, because it's half of the focal length, and 1, 2, 3, 4 to the left, and boom. And now that we're doing it together, I guess I should have added something to this. After the vertex, you should really put the axis of symmetry to help yourself out. Since this is an x squared, the axis of symmetry is going to be the h, so in that case it'd be an x equals 0. And since you know the axis is an x equals, then you'll know that the directrix is a y equals. Okay? These are things you're just going to start learning and understanding as time goes on. My directrix is y equals negative 2, and bada bing, bada boom, you're done. Again, I don't expect you to have memorized the formulas already today. That's why I gave you these sheets. That's why you could go back to your notes. Okay? Let's do a little bit more complicated now. Now, I want to find the equation this time of a parabola with a vertex at 0, 0 and a focus of 5, 0. What kind of a graph, an x squared or a y squared, has a value on the focus that is different than the vertex, guys? Is this going to be a y squared or an x squared? This is going to be a y squared, guys. This is going to be a y squared. And this is how you can tell. Shh. First of all, this 0, 0 is my vertex, correct? Isn't 5, 0, 1, 2, 3, 4, 5? Isn't that my focus? Doesn't that tell you how it's going to open? So it's going to open like that, right? Okay, that's a y squared. So we know it's a y squared right off the bat. That's going to help us. My vertex, they already gave it to me. My focus, they already gave it to me. Excuse me. Now, my directrix. Okay. What would my directrix be here? Why would it be x equals negative 5? H equals 0. It's going to be h minus a. And in this case, my a is 5. Correct? Because how do I know? Because my focus is h plus a. I know my h is 0 because my vertex is 0, 0. Okay? I don't need a test point. My lattice rectum will be as follows. Or actually, you know what? In this case, do I know what... Oh, yeah, I know what my a is, though. My a is 5, right? So, isn't the lattice rectum 4 times a? So my lattice rectum length will be 20. Give me 1 second. Okay, guys, so now we have everything we need to write the equation. This is a y squared equation. So this is going to be y minus k squared, remember, equals 4a times x minus h. Just plug and chug, guys. So this is going to be y squared, because there is no k value, it's 0, equals the lattice rectum, which is the 4a, so that's 20, times x. That's my equation. I already have my vertex. I already have my focus. Let's go ahead and put my directrix here at x equals -5. 1, 2, 3, 4. There's my directrix. Sorry, it's getting a little jumbled up in there. And then my latus rectum is 20. So my focal length. So go 10 up, 10 down from the focus. And bada bing, bada boom. That's my parabola, my brothers. Guess what? Have you guys ever enjoyed satellite dishes? Okay, if you watch TV, which you all do, that's what a satellite is. It's a parabola. It's a sideways parabola, to be exact. It's a non-function.
So people build satellites.
People that build satellites, okay, have to graph this because I don't know if you've ever seen a satellite dish, but the satellite dish comes out like this, right? And then there's like a little transmitter here. You ever seen that? That's the focus. Okay, that's the focus, guys. All right, so that's how this works. Now, let's continue, please. Let's continue, please. Find the equations of parabolas with vertex at 0, 0 if its axis of symmetry is the y-axis. So let's think about that. Let's first qualify this statement. If the axis of symmetry is the y-axis, what does that mean that the axis of symmetry is? No, guys. The axis of symmetry is either an x equals or a y equals. If it is parallel, if it is the y-axis, isn't that an x equals 0? Guys, because that's my axis, and that's an x equals 0. You with me? Okay, so let's think about this now. And then we have a point on the graph that is 4, 3. So if my axis of symmetry is 0, 0, my vertex is 0, 0, my vertex is 0, 0. Now, I need to find my focus and my directrix and my latus rectum. Well, this time I am going to have to use some equation stuff. I know that this is going to be an x squared equation. I know that x squared equals 4ay, right? When I have a 0, 0 as my vertex. So I have this point here, 4, 3. So I'm going to have 16 equals 12. No, what am I doing? What am I doing? Come on, man. Get on it, Mr. Morrow. Wow, epic fail. Yeah, no, I am right. Yes, I am right. 4 times 4, that's going to be, so that's 12a. Okay, divided by 12 to both sides. A equals 4/3. So now that A equals 4/3, I can find my focus. Because my focus is going to be H, K plus A, which is 4/3. My directrix is an x equals axis. My directrix will be a y equals, and that's going to be y equals k minus a, so that will be a negative 4/3. So my equation is going to be x squared equals 4 times a, so that's 16/3 y. That's my equation. Let's graph it. 0, 0 is my vertex. 0, 4/3 is my focus. So 4/3 is basically 1 1/3. So about here, about there. My latus rectum is 16/3. So half of that is going to be, half of that, that'll be 8/3, correct? Yeah. So 8/3 to the right, 8/3 is 2 2/3. So that's about there. 2 2/3 to the left, 1, 2, 1, 2, 2 2/3 there. My directrix is a y equals negative 4/3, which is 1 1/3 negative. And there's my graph. Okay? Okay, I still have 2 more, guys. I still have 2 more, so the more time you guys want to complain, it's going to be the more time we got to stay. Because I'm finishing today. Now, Let me continue with the last two. Okay, now graph this equation. Okay, remember how we completed the square, guys? We're going to have to use that format again. First of all, always identify who's squared. In this case, the x is squared. So I am going to use x minus h squared equals 4a times y minus k. That's what I want to turn this into. So let's do it. Let's go ahead and get the x squared minus 2x alone. And let's send over the 8y and the 25. So that equals 8y, negative 8y, minus 25. I'm going to complete the square. So I'm going to go plus negative b over 2, which is negative 1 squared, to both sides. So this is going to give me x minus 1 squared equals, this is going to be negative 8y minus 24. So I'm going to have, in the end, I'm going to factor out a negative 8 there. So I'm going to have negative 8y plus 3. That's the equation that I'm going to deal with. And now it should be Mickey Mouse from here. My vertex is hk, so 1, 3. Okay? My focus is going to be, remember, when it's an x squared, the h from the vertex is the same x value for your focus. So it's going to be 1, comma, and this is going to be negative 3. 1, negative 3. Why? What's the formula for the focus of an x squared? It's h, comma, k plus a. What is my a here? Negative 8 equals 4a. So divide by 4. A equals negative 2. So what is my k here? What is my k here, guys? It's going to be negative 3, right? Bam, negative 3. Okay? You with me, guys? Hello? And I'm sorry. It's not negative 3, it's negative 5. Sorry. Because it's k, which is negative 3, minus plus a, which is negative 2. My directrix, since it's an x equals axis, it's going to be a y equals directrix. And y is going to equal, this time for the directrix, k minus a. So k, which is negative 3 minus 2, you're going to have negative 1. Minus the negative 2 is going to be negative 1. You don't need your test point. You know your lattice rectum is negative 8. So the absolute value of that is going to be 8. So now I have 1, 3. 1, 3. That's my vertex. My focus is 1, negative 5. So this is going to point down or up? Down, and you know it's going to point down because that's negative. My directrix is y equals negative. Wait, something's wrong here. I'm sorry. My vertex is 1, negative 3. Pay attention, doofus. 1, 2. Sorry about that. My directrix is y equals negative 1. My focal length is 8, so from the focus go 4 to the right. 1, 2, 3, 4. 4 to the left. 1, 2, 3, 4. And I have my parabola. I suggest you take your time tonight and watch this video over and over and over. Now, I know you're going to kill me, but I got to do one more. I'm sorry. I want to be accurate, and I want to help you guys. Now we're going to look at a y squared one. Let's just do it fast. Let's complete the square. I got y squared minus 4a plus b over 2 squared, which is negative 2 squared. That equals, bring over the x and the constant. So I'm going to have 12x plus 32 plus the b over 2 squared, so plus 4, which is 12x plus 36. So my formula is going to be, my equation rather, y minus 2 squared equals 12x plus 3. I just factored it out. Now my vertex, be careful, when it's attached to the y, it's the k. So my vertex is negative 3, comma 2. Okay? My focus will be 0, comma 2. Please remember that the focus equation for a y squared is h plus a, comma k. Remember the k stay the same here. And your h is 3, okay? And my a in this case, my a, if I have 12 equals 4a, my a equals 3, so 3 minus 3 is 0. That's how I got that. My directrix, since it's a y squared, it's going to be an x equals, and it's going to be x equals h minus a, which gives me negative 6. We don't need a test point anymore. We're looking for the lattice rectum, which we know is already 12. So the absolute value of that is 12, and that's my distance. So, now the easy part. Vertex, negative 3, 2. Focus, 0, 2. Directrix, x equals negative 6. 1, 2, 3, 4, 5, 6. My lattice rectum is 12, so from the focus, 6 up. 1, 2, 3, 4, 5, 6. 6 down. 1, 2, 3, 4, 5, 6. And connect the dots, and you are done. How did I get the focus? Well, the focus is h. No, in this case it's a. The focus, yeah, h plus a, comma k. What is my h here? Negative 3. What is my a here? Positive 3. So negative 3 plus 3 will be 0. Look, Pablo. You got it? My a is 3, and my h is going to be negative 3. Guys, listen up, please. I know you can do this. I believe in you. But you got to memorize these formulas. Thank you, guys. Thank you for spending the extra 10 minutes. May God bless you and have a great day. Thank you, thank you, thank you.